this lecture, we will introduce some statistics functions for Pandas data structures. Most of the statistical functions for NumPy arrays are still valid for Pandas data frame, so using the apply function is no longer necessary. For example, functions such as sum and mean can calculate the sum and the average respectively of the elements contained within a data frame. So frame is data frame with 4 columns and 4 rows in the index. Then if we write frame.sum parentheses, then it will calculate the sum for each column of the data frame, and the result is a series type with the index the same as the original data frame's column name. And if you want to calculate each sum of each row of the data frame, we can add axis equals 1 here. Then the result will be also a series, and the index is same as the row index of the data frame. The mean function, frame.mean, can calculate the mean for each column of the data frame, and accumulation of each column or row. So frame.sum cumulative sum, then the result will be a data frame. If we not add axis here, then the calculation will be for each column accumulation. And if we write axis equals 1 here for the cumulative sum function, then the result will be accumulation for each row of the data frame. And describe function allows you to obtain a summary statistics. So we write frame.describe, then the output will be information for each column of data frame, and the index here will be count, mean, standard deviation, minimum value of each column, and a 24% percentile value, 50% of the median value, a 70% percentile value of each column, and the maximum value. A correlation and a covariance between two series. Though this is a two series, here have the same index for these two series. If we write the first series, then dot COR means correlation, the parentheses the second series, then the result will be a number between 0 and 1. And if we write first series, then dot COV means covariance, and inside the parentheses is the second series, then the result will be here, but not necessarily between 0 and 1. And a covariance and a correlation can also be applied to a single data frame. In this case, they return their corresponding metrics in the form of two new data frame objects. So for example, frame 2 is a data frame with 4 columns and with 4 rows. Therefore, we write frame2.cor. So the correlation between different columns will be shown in the matrix. Can you see, for example, correlation between ball and pencil will be minus 0.27, and the diagonal will all be 1. And we can also write data frame.cor, then the covariance between the columns will be shown. You can see the covariance number is not necessarily between 0 and 1, but the absolute value can be larger than 1. And if we use the COR with method, you can calculate the pairwise correlations between the columns or rows of a data frame with a series or another data frame. So for example, this is a series with 5 index, and we see the frame 2 is a data frame with 4 column variables and 4 index values. So if we write frame2.cor with series, the result will be a series, and with the index only with the value are common between these data frames column variables and this series index. So here only 4 rows in the index inside this resulting series, and each value is the correlation between one of the columns of data frame and this series. Then if we write frame2.cor with frame, then the result will be a series, and the value for each index is the correlation between first column of each of the first data frame with the column of the second data frame. Only for these two same columns, then it will be possible to do the calculation. We will show all these statements in Anaconda Spider now. So we see the file called section 11 introducing pandas library.py, and the links to this file will be found in the description of this video. Then we move to lecture 8, statistics functions. First we import these two libraries, then create a frame, data frame. Then we use frame.sum. The result is by column. Bow is the column variable. For each column, the sum, if we add axis equals 1, then the sum of each row, the red, blue, yellow, white. And if you write the mean value for the column, each column's mean value, and then cumulative summation for each column, by column, sum, accumulate. And if we add axis is 1, then row wise accumulation. If we write dot describe, then the descriptive statistics will be shown for each column. Now correlation and covariance. Create two series. Then the correlation between these two series, 0.77, and covariance 085. Create another data frame. Frame 2. Then the frame 2's correlation will show. So this is for the matrix for the correlation for the frame 2 data frame itself. So the ball to ball is 1, pen to pen is 1, but ball to pen is minus 0.27. And covariance, similarly, covariance, the number absolute value can be larger than 1. We'll create a series with a 5 value, this series. Then the data frame's correlation with this series, because the data frame has only 4 indexes, so this 4 is for the data frame's column. Each column is correlated with this series, the value. So the ball is correlated with the series, and their correlation is 0.73. And the pen's column in the data frames, the correlation with series is minus 0.83. And the correlation between two different data frames, the result will be a series, and index of this series is the common column variable names for these two data frames. Because these two data frames has 4 columns each has 4 column variables: ball, pen, pencil, paper. So the correlation between these same column variables are possible to calculate. So the ball column, the correlation between the ball column in the first data frame and the ball column of the second data frame, correlation is 0.73. And the correlation between the column of pen in the first data frame and the column of pen in the second data frame, the correlation is minus 0.83, and so on.